Hello students, welcome to Marine Engineering Tutorials. I am Atul Kumar Gupta and back with a new tutorial. Presently we are studying Marine Auxiliary Systems and Deck Machinery. Today we have 15th lecture and the topic is shell and tube type evaporators. In this tutorial, we will first learn about the construction of shell and tube type evaporators. Then we will discuss the flow of various fluids, their control and monitoring parameters. Lastly, we will see the typical parameters of a freshwater generator obtained during the sea trial of a ship. Let's discuss these through the following slides. Construction of shell and tube type freshwater generator. This sketch shows the construction of shell and tube type freshwater generator which is used on motor ships. It uses the principle of flash evaporation and utilizes the waste heat of propulsion engine contained in the jacket cooling water for evaporation of seawater. Freshwater generator consists of a separator shell made up of steel plates which is internally lined with neoprene to prevent its corrosion. Upper part of the shell contains a shell and tube type of condenser whose shell is open from the top for admitting the water vapor for their condensation. Shell is made up of stainless steel and aluminum brass tubes which are attached to naval brass tube plates on both ends. Neoprene coated cast iron and covers for the condenser are outside the freshwater generator shell through which seawater is circulated in the tubes and also provide access for their maintenance and repair. A shell and tube type evaporator is bolted to the bottom of freshwater generator shell. Evaporator shell is made of steel plates and consists of a bundle of straight vertical aluminum brass tubes expanded into naval brass tube plates. A glass fiber baffle attached on top of the evaporator prevents the carryover of seawater droplets along with the evaporated vapors. A side glass is provided on the freshwater generator shell to monitor the supply of feed water and check the brine level during operation. It is also used to admit the descaling liquid in the evaporator tubes for maintenance when freshwater generator is stopped. A demister made up of monol wires prevents the carryover of seawater droplets and helps in limiting the salinity of evaporated water below 5 parts per million. A rubber-lined steel cover seals the freshwater generator shell from the top and allows its internal inspection. A dish-shaped cover internally coated with neoprene seals the evaporator from the bottom and holds seawater in the tubes. Cooling seawater is circulated through the condenser tubes through inlet and outlet connections on the condenser pipe and cover. Air is removed from the shell through its outlet, and the air ejector helps in maintaining vacuum in the shell. A swing check valve equipped before the air ejector prevents backflow of air and seawater. Seawater feed is supplied to the evaporator from the bottom cover of freshwater generator. Excess seawater feed supplied to the evaporator is removed as brine from its outlet through brine ejector. Engine cooling water supplied to the evaporator shell through inlet and outlet connections is circulated around the tubes for heating the seawater. The baffle plates provided assist in uniform heat transfer. The condensate collected in the condenser shell is drawn by the distillate pump from the freshwater outlet connection. Freshwater generator flow diagram. This sketch describes the functions of various equipment used in freshwater generator and also shows the flow of different fluids taking place through the freshwater generator. The description is in accordance with the starting procedure of freshwater generator. Before starting the freshwater generator, evaporator drain D1 and vacuum breaker valve V1 are closed. After setting the seawater line, ejector pump EP is started and its pressure is monitored by the pressure gauge P1. Seawater passes through the air ejector E1 and the brine ejector E2 and starts drawing air and brine through their respective check valves CV1 and CV2. Vacuum created in the shell is monitored by the pressure gauge P2 and air trapped in the condenser water box is released from the vent valve V2. When the shell attains 90% vacuum, seawater is admitted through the regulating valve RV, whose pressure can be monitored by the pressure gauge P3. The orifice plate O reduces the feed water line pressure, whereas the strainer S traps any dirt in the feed water supply. The back pressure valve B stops the feed supply if the vacuum drops below 90%. Flow of jacket cooling water is regulated by adjusting the bypass valve and monitored by the inlet and outlet temperatures from the thermometers T1 and T2. Any trapped air in the evaporator shell is removed from the vent V3. Some ships are equipped with steam heating arrangement for operating the freshwater generator when the ship is in port. In this system, the steam is admitted through the ejector E3, which is circulated through the check valve CV3, and the condensate drains to the hot well. The shell temperature is recorded from the thermometer T3, which is dependent on seawater or the condensation temperature. Performance of condenser is observed by monitoring the inlet and outlet temperatures from the thermometers T4 and T5. When the condensate level is visible in the condenser shell, the distillate pump DP is started, whose pressure can be monitored from the pressure gauge P4, and the level is regulated manually. The condensate passes through the salinity cell SC, whose salinity is displayed by the salinometer SM. If the salinity of the distillate is more than 10 ppm, the solenoid valve SB automatically dumps the condensate to the brine through the check valve CB4, which closes when the salinity drops back. The drain valve D2 can be used to taste the water. The flow meter FM measures the freshwater generator output, which is supplied to the freshwater tanks. The check valve CB5 prevents backflow from the tanks. While the freshwater generator is in operation, the chemical dosing pump CD continuously doses chemical to prevent scaling in the evaporator tubes. The freshwater generator shell is protected by a relief valve against any overpressure. Typical parameters of 30 tons per day capacity freshwater generator. This sketch shows the typical parameters of a 30 ton per day capacity freshwater generator obtained during the sea trial of a ship. Corresponding to 32 degrees centigrade as the seawater inlet temperature, shell is maintained under vacuum of minus 83 kilopascal with corresponding shell temperature of 57.6 degree Celsius. 4,200 kg per hour of seawater at temperature of 51.4 degrees Celsius is supplied to the evaporator as feed. 58 meter cube per hour of jacket cooling water at temperature of 85 degrees Celsius is supplied to the evaporator for heating the seawater. Jacket cooling water is discharged from the evaporator at temperature of 72.4 degrees Celsius. (2950 kg per hour of seawater is discharged from freshwater generator as brine. 70 meter cube per hour of seawater at temperature of 32 degrees Celsius is applied to the condenser for condensation of steam. Seawater at temperature of 42 degrees Celsius is discharged from the condenser. Part of the seawater, which is usually 3 to 4 times of the desired output, is taken out from the condenser outlet, reheated in the shell, and supplied as feed water to the evaporator. 1250 kg per hour of distillate at temperature of 55.6 degrees Celsius is discharged from the freshwater generator. This completes the study of shell and tube type freshwater generator. This book is written by me and covers all the topics as per the syllabus specified by Indian Maritime University. It clarifies the concepts with simple illustrations. The book also provides answers to all the questions which have appeared in the examination conducted by Indian Maritime University. The book can help the students in preparing for the exam and also to work on ship's auxiliary systems and deck machinery safely. Hope that you have liked the lecture. You can write your feedback in the comment box. If you have liked the tutorial, you may share it with your friends. You may subscribe to the channel for getting notification about the new tutorials. I will be back with a new lecture shortly. Thanks for watching till the end.